So let's get deep into the weeds, shall we? You tell me, you mentioned about ZeroFace, one of your most highlighted arsenal and tool in your toolkit. So how does it exactly work?
Sure. So it works in a very interesting way. So we use, as you might guess from the name zero in everything, right? We've zero biometric, ZeroFace. You're going to hear zero something many more times as we talk. Zero knowledge proofs are a big part of how we work. And fundamentally, we start with the premise of, how do we authenticate you without knowing what you look like? Which is an interesting problem. Right, I'm sure we'll talk more about zero knowledge proofs, but the way that we work is that we look at your face. Our software will look at your face, usually embedded in an application on a mobile phone, and we'll look at your face, and we will generate a formula looking at stable features of your face that will describe your face and produce a one-way hash result of what your face, not exactly what your face looks like, but where there's interesting information in your face. And when you apply your unique formula to your face, what would the results of that formula look like as expressed in a hash? That's very different, by the way, than the way normal biometrics work, where they're basically taking a picture of your face, they're vectorizing it, and then they're saving it out. But it's still a reversible thing. I mean, this, you may not know it, but there's been plenty of research articles showing that you can take a saved face template and reverse it back into a photo. Well, we don't save any biometric information. We save, a formula that will describe your face, where to look for interesting things and what that result should be. We save that. We call it a zero map. And then when you come back to authenticate, then your face is compared to your zero map. And if the result of that formula gives the exact same hash output as what was initially recorded, then it's a match. But it has to be exactly the same output. If it isn't, it fails. It's very different, right? Face, traditional face, they take a picture, they save it, they take another picture, and then they do a difference comparison to see, well, how similar is this earlier photo of Dave to this brand new photo of Dave? It's a probabilistic sort of approach.
Yeah, that is actually, I was going to say exactly the word. So basically what you're saying is early approaches is more probabilistic in nature, but zero face is kind of binary, right?
Yes.
So if it's 100% match, it will authenticate. If it's not, it will deny you the access.
Mm-hmm.
Right. So, so for folks who don't know exactly how these cryptographic functions work, you could imagine like a mathematical formula. Okay, you could imagine a function which it will have some parameters. Okay, so you're feeding into the parameters, and then you're creating a cryptographic, key, so to speak, or you are kind of hashing it. That's what we call it.
We're creating a hash output.
If you
Yes.
Yes. So if you change even a single parameter, even a tiny bit, you will get a completely new hash, completely different hash. Completely different, you could say 256 bits. So I believe, do you use SHA-256?
Yes, we do.
Okay, all right. So that's basically it. Kind